Hey everyone, here's a video on solving quadratic inequalities using both the calculator and without the calculator, so solving algebraically. So that way you can do it at home whether you have a calculator, a TI Inspire calculator, or not. So let's get started. On this first one, on these first two examples, we're going to be using the graphing calculator. The first one we're going to be looking at is x squared minus 6x plus 8 is less than or equal to 3. The other one is greater than 3. You'll notice that we have an inequality sign instead of an equal sign here, but really it's pretty similar whenever we are solving these. We have a couple different options whenever we're using the calculator. You can either put it in as two separate lines, or two separate graphs, where this is one of the graphs and this is another. Or you can subtract it over so that it's equal to 0, and then look at the x-intercepts. But let's switch over to the calculator so you can see what I'm talking about. Okay, so you can see here we're now on a graph. I'm just going to type in the first part, which was x squared minus 6x plus 8. So there was the parabola, that was the left-hand side of the inequality. And then I'm going to type in the other part, the 3. So here's my graph, and then I'm going to look at the intersection between these two things by going to Menu, Analyze Graph, Intersection. And so I'll click on the left and right so I can find this point, which is 1, 3. And then I'll do the same thing for the other. Menu, Analyze, Intersection. Click on the left and right for this point, which here is 5, 3. So our inequality was x squared minus 6x plus 8 is less than or equal to 3. We're looking for the solutions that make that true. So in other words, we're looking for where the parabola is less than or equal to this line of 3, and we're looking for the x values that give us that true information. So you can see that we have 1 and 5 are the x values that are related to this graph. So let's switch back over to the other page so we can write down our answer. Okay, so I brought my graph over to this page. So for this one, we're seeing where is x squared minus 6x plus 8, where is that less than or equal to a y value of 3? So in other words, where is the parabola less than or equal to 3? Well, if I go ahead and just color on this picture here, that's this part right there. And notice that it's an equal to, so we're including those points as well. So our solution here is going to be 1 is less than or equal to x is less than or equal to 5, because those are the x values, that 1 and the 5, that allow this parabola to be less than or equal to 3. Whereas on this other one, we're looking for where it is greater than 3. That's this part up here. And here it's not an equal to sign, it's just a greater than sign, so we're not going to include the actual points, just everything up until those points. So that would be, this is going off towards a negative infinity, so we'll have all of the x values that are less than 1, or all of the x values that are greater than 5. And by the way, you can write these in interval notation if you like, which here would be 1 to 5 with the brackets because we're including those points. Over here, we would use parentheses, negative infinity to 1, union, which means or, 5, parentheses, infinity. And that's it for this one. Okay, let's look at this example where we're going to solve it algebraically without the graphing calculator. What we're going to do is set it up into an equation so we can solve this like we've done before. So I'm going to make this into an equal sign. X squared minus 4x plus 1 equals 6. And I'm going to solve this like before, where I'm going to subtract the 6 over. So I'm going to have x squared minus 4x minus 5 equals 0. Then I will factor this into x minus 5 times x plus 1. I have two factors multiplied together that equals 0, so I'm going to set each of them equal to 0 and solve for x. So x equals 5, x equals negative 1. So to figure out whether I'm going to have an or situation or the and situation, like seen before in example A, that was an and. The example B was an or because we had the two separate parts. I'm going to draw a number line. I'm going to put on there my critical values. These are called critical values, as -1 and 5. So here's the -1 and here's the 5. And to figure out which x values to include, I'm going to test points from each region. So I'm going to start out by testing a point -2 right here. So I'm going to plug in -2 into this equation. So I'll have -2 squared minus 4 times -2 plus 1. Is that greater than 6? So we have 4 plus 8 plus 1. Yes, that is greater than 6, so I'm going to shade that part of my graph. Testing a value for 0. I'm going to again plug it back into that same equation. So 0 squared minus 4 times 0 plus 1 greater than 6. Is that true, that 0 minus 0 plus 1? So is 1 greater than 6? No, that doesn't work. So we're not going to include that part. But then let's test 6. So if I plug in 6 back into that equation, 6 squared minus 4 times 6 plus 1 greater than 6. Is that true, that 36 minus 24 plus 1 is greater than 6? Yes, it is. So I'm going to include that part as well. Now, as for the critical values themselves, I'm going to refer back to my equation. I see that it's not an equal to, it's just a greater than. So I will put open circles on those points and then write down my answer. So here I will have an answer of -infinity to 1 union 5 to infinity. You could write this also as the x values, oops, that should be a -1, x values less than -1 or the x values greater than 5. That's the answer. Okay, let's look at one more example. Here's a problem-solving application. A business offers tours to San Antonio. The profit P that the company earns for X number of tourists can be modeled by this function, P of X. How many people are needed for a profit of at least 500? So let's start out by putting this into an inequality. Our profit function, which is -2.5x squared plus 100x minus 300, that's the amount of profit that we're getting. That has to be at least 500, so it must be greater than or equal to at least 500. So just like we did before, let's put this into an equation and solve. So I'm going to make this inequality an equal sign. Now I want this equal to 0, so I'm going to subtract the 500. So I have a function that is equal to 0, and we can use the quadratic formula here. If you want to make it a little bit easier on yourself, you can factor out the -2.5 to the front, and you'll be left with x squared minus 40x plus 320. And then you can just do the quadratic formula on the part that's left in the parentheses. So we'll get x equals -b, so negative of -40 is 40, plus or minus the square root of -40 squared minus 4 times a, which is 1, because we're just inside the parentheses, times c, which is 320, all over 2 times a, which is 1. And then whenever you evaluate that, you'll get x is about equal to 28.94, or x is about equal to 11.06. So then let's check the number line again. So let's plot the critical values of 11.06 and 28.94 on the number line. And again, let's test the values in each region. So if I test 10 here, if I plug 10 back into my inequality here, I want to see if the left-hand side will be greater than or equal to 500 when I plug in 10 in for x. So if I plug in 10, the left-hand side will be equal to 450. And is that greater than or equal to 500? Yes, it is. So, oh, I'm sorry. Silly me, is 450 greater than 500? That's ridiculous. No, sad teacher. That was wrong. Okay. Let's make that an x for no, 450 is not greater than 500. Okay, so for the next part, if we plug in a number in between 11 and 28, let's pick 20. If we plug in 20, we'll get a value of 700. Is 700 greater than or equal to 500? Yes, that is greater than or equal to, whoa, greater than or equal to 500. That's true. So we'll shade in between here. And then let's pick one more value. If we pick 30. If we plug 30 back into that left-hand side of our function, our inequality, then we'll get 450. And is 450 greater than or equal to 500? We already discussed that over here. No, that is not greater than or equal to 500, so we're not going to include that. And notice our inequality is an equal to, so as for the critical values, we'll put closed points here. But because we are in an application problem, we can't have 11.06 people or 28.94 people. We want to make these whole people. So we cannot have a fraction of people. So we want to pick, we want to round these numbers so that way the people that we have still fall in the shaded region. So this 11.06, let's round up to 12 because 12 is included in the shaded region. So 12 is less than or equal to x, which is less than or equal to. So if we have 28.94, you may be tempted to round it up to 29 people, but 29 is not included in the shaded region. So we actually need to go back one to 28. So we need between 12 and 28 people for a profit of at least 500, and that's our answer. Let me know if you have any questions, and I will see you later. Bye.